what's going on for 3.1? A school guidance counselor examines how many extracurricular activities students participate in and their grade point average. The guidance counselor says the evidence indicates that the correlation between the number of extracurricular activities a student participates in and his or her grade point average is close to 0. Which one is the most appropriate conclusion? So again, let's say, for example, you're in like 5 extracurricular activities. So like you're in the band, you're in the theater, you play water polo, you play basketball, and you do track and field. Okay, so you're a very busy person. And they're saying that the correlation between the number of extracurricular activities and the grade point average is close to 0. So what conclusion can we make? So you want to be careful here, because if they say the correlation is 0, it means that there's really no relationship. So A and B don't make any sense, right? Like students involved in extracurricular activities have bad grades, or students with good grades don't have any. Like that would be if you had a positive correlation. Negative correlation would be both A and B. If you had negative correlation, you'd have 2 answers. You can't have 2 answers. Students involved in extracurricular activities are just as likely to get grades as bad grades. Yeah, I mean, still, you have to be careful with that statement. Look at D, students with good grades tend to be involved in many. No, that's a positive correlation. No conclusion should be based on the correlation without looking at a scatter plot of the data. I would totally agree with that. Because you really need to see what's going on there. Like for example, is a scatter plot looking like this? So let's say this is GPA and number of activities, right? I mean, it's very likely that GPA stays flat. So that would be 0 correlation. So that's very, very possible. Maybe everyone's GPA is 3.0, regardless of how many activities you play. So you're not sure that whether they're getting good or bad grades, or it could be kind of all over the map like this. So we really don't know. That's why it's E. So now I'm going to have how many more questions we got then? 10 more choice. So we got 9 people's class. So I'm going to have just one person, one at a time, just read the question to me, and then we'll kind of talk about the answers together. So Teddy, I see you up next. You mind reading question number 2 on my screen here, please?
Yeah. An AP statistics student designs an experiment to see whether today's high school students are becoming too calculator dependent. She prepares 2 quizzes, both of which contain 40 questions that are best done using paper and pencil methods. A random sample of 30 students participates in this experiment. Each student takes both quizzes, one with a calculator and one does without, in a random order. To analyze the data, the student constructs a scatter plot that displays a linear association between the number of correct answers with and without a calculator for the 30 students. A least square regression yields the equation calculator equals -1.2 plus 0.865, pencil R equals 0.79. Which of the following is true?
Okay, perfect. Thank you. So, which of the following statements is true? So, if we look at the number of correct answers with and without calculator, okay. So that one actually seems a little confusing, actually, because I'm trying to understand what X and Y represent here. I'm assuming Y represents your quiz score. Yeah, I'm not 100% sure what X are representing. It seems a little confusing, actually, to be honest with you. But the one thing is that if you do switch the explanatory variable, the correlation stays the same. So that's just something you should know. So regardless of like what we're doing in the situation here, because what they're trying to do is they're trying to see, I guess, if you did it without a calculator, oh, I see what they're trying to do. Okay, I get it now. This is your score without a calculator. And this is your score with a calculator. Okay, I got it now. This should be a little more explicit. This is a terribly worded question. So score with a calculator is Y, score without is X. And let me write that more neatly. This is terrible. I can do a better job. Sorry, guys. Let's try this again. Score without a calculator. That's much better now. Okay. And let's move that. Score with the calculator. Okay. Yeah. Again, I think the question was worded kind of terribly. So, say for example, like there's 40 questions, right? So you can get 40 is the most correct. We'll say it's 10, 20, 30. So say, for example, your score was a 20 without a calculator, 40 with a calculator, right? Or say, for example, another person scored a 40 without, but 20 with a calculator. So that's kind of what we're kind of talking about here. So if you switch those variables, the correlation would stay the same. That is definitely true. If say calculus exponential, the slope of this curve would, well, slope would change because the slope is a change in y or change in x, where y is a score with a calculator scores and x is a score without. So if you switch y and x, of course the slope is going to be the reciprocal. So that's out. The standard deviation, the number of correct answers on the paper pencil quiz was smaller than this deviation. That's a tricky one. So this is where you have to use your formulas. I know it's kind of confusing, but b is actually going to be the slope here. So we tend to write these as y equals a plus bx. I know it's kind of weird, but the slope is this formula right here. So if you put 0.79 for r and 0.865 for the slope, and you would realize that if you were to isolate sy, the standard deviation of y, it's 1.095 times sx. What this tells me is that sy is definitely bigger because 1.095 times sx. So the standard deviation of x means the score using with a pencil definitely has a lower standard deviation, which is true. And that's why it's D. So that's how you interpret that one. Okay, so thank you, Tay, for reading. And now I'm glad we got that out of the way. Will, I see you next. And by the way, great win by the Colts. I think that was what, on Monday night?
Thursday.
Oh, the previous Thursday. That's right. Yeah, that's right. Yeah, I had a lot of Tennessee players in that game, and I wasn't too happy. But yeah, good one. You got your guys looking good. You guys in the driver's seat. Anyway, can you read the top part and number 3, please?
Sure. Refer to the following setting. Scientists examined the activity level of 7 fish at different temperatures. Fish activity was rated on a scale of 0, no activity, to 100, maximal activity. The temperature was measured in degrees Celsius. A computer regression printout and a residual plot are provided. Notice that the horizontal axis on the residual plot is labeled fitted value, which means the same thing as predicted value.
Okay, thank you. So first off, let me help you read this. It's not that hard. For now, you can ignore this and ignore this. These are things we'll talk about later in the year or school year. What I do care about is this. So constant means a y-intercept. So your y-intercept is 148.62. And the temperature, that's going to be our x value. So x will equal temperature. And apparently y is going to be activity level. So, and this is y hat, the predicted value. And this is going to be your slope, negative 3.2167. So let me change that to a minus, actually. minus 3.2167 times x. So that's your slope. Change y or change in x, or the change in activity level over the change in temperature. So you can see that if the temperature is a positive change, the activity gets low. So apparently fish are more active when it gets colder. That's what we're seeing here. And also R squared is 91%, or R squared is 0.91. If you use a graphing calculator or just any calculator, you take the square root of 0.91. So got this right. Root of 0.91, you get 0.954. So that's your correlation coefficient. And because they're going in a negative direction, because it's technically plus or minus, and because we see a negative slope, that indicates that when temperature goes up, activity goes down, vice versa. So it's actually negative 0.95, not A, just so you know. And then for number 4, Aiden, do you mind reading number 4, please?
Sure. Number.
It's on my screen.
Oh, okay, yeah. What is the actual activity level rating for the fish at the temperature of 20 degrees Celsius?
So you have your formula here. That's y hat. Let me make it a little easier to see. So you throw 20 into that and work it out. That's all you gotta do. And you should get 87. So that's that one. But you have to really write the equation from the information here. And then finally, so Mel, I see you. Can you read number 5, Mel, please? And Mel is not there. Isabel, can you read number 5, please?
Yep. Which of the following gives a correct interpretation of S in this setting? And then do you want me to read all of them or just the right
No,
one?
that's okay. You're good.
Okay.
So this is a big one. And we have to read this carefully. So we have to look at the slope, right? The slope, again, is telling us that, because temperature is x, and temperature change y or change x. So this means that for 1 degree Celsius increase, activity level drops by 3.2167. Because remember, it's seeing change y or change x is slope, and x is temperature, y is activity, and it's negative 3.2167. So you think it was negative 3.2167 over 1 equals that. And so that's why a temperature of 1 increase, the activity decreases. So the activity does not increase, so A is out. The typical distance, that makes no sense. Of temperature readings from their mean. Let's come back to that one in just a little bit. E makes no sense because the R1 is just 148.6. So E makes no sense. Because we haven't talked about typical distance. Let me read that one more time. The typical distance of the temperature readings from their mean. Okay. Yeah, that's. Oh, the meaning of S. Oh, shoot. I didn't see that. We have to throw this question out. Sorry. We've not done that yet. We'll throw that question out. My apologies. What I could ask is, what is the meaning of the slope of the regression line? And that's how I would interpret it. I could ask that. Sorry, I totally misread number 5. My apologies. And number 5 actually was not a fair question for you guys because we've not done that yet. So, but hopefully that makes sense. For every 1 degree Celsius increased activity level drops by 3.2167. And also for temperature 0, the activity level is 148.6. Those should make sense from the least squares regression line. Okay, John, I see you next. Would you like to read number 6 for us, please?
Sure. Which of the following statements is not true of the correlation between R between the lengths
Okay.
in inches and weight in pounds of the staple
Brook trout. Okay. So okay, so sorry, I thought 6 dealt with the data, but it doesn't. This is totally different. Okay. Just because I know they're talking about fish here, so I got confused. 6 is a standalone question. Which one is not true? Definitely R is between -1 and 1. We know this. So check. Let me use green actually. R is unitless though, just so you know. Doesn't have any units whatsoever. Here, if longer trout tend to be heavier, so you're gonna have a positive correlation. So yeah, totally R is bigger than 0. R would not change but measure the lengths of trout in centimeters. Who cares if you change the units? That doesn't matter. It's still gonna correlate. So it would not change. R would not change measure the weights. Yeah, doesn't matter again. In case you forget, there is a formula for R. It's right here. And you can see that what you're doing is you're multiplying the change in X with the mean and the change in Y. This means kind of summing the product of those differences, and then do the square root of the sum of their squared differences, or the differences squared, I guess. The thing is that the units are going to come out the same though. Like X, let's say, is inches, and that's like in kilograms. That'll be inches squared in kilograms squared. But then you're square rooting it, giving you inches times kilograms anyway, and these cancel. So R is going to be unitless. So they're not going to be units for R, just so you know. And that's why the answer would be. Okay, 3.7. Zach, do you mind reading 3.7 for us, please?
Yeah. When we standardize the values of the variable, the distribution of standardized values has mean 0 and standard deviation 1. Suppose we measure two variables x and y on each of several subjects. We standardize both variables and compute the least squares regression line. Suppose the slope of the least squares regression line is 20.44. We may conclude that.
Okay, thank you. So remember, the equation for a least squares regression line is this: y equals, I know it's kind of weird, because usually think b is y-intercept, but it's going to be that. And your total slope is 20.44. Again, I don't know what a is yet, but you are given the standard deviation. And the mean. And they said that we standardize the values of a variable distribution, and we suppose we measure two variables, x and y, and we standardize both of the variables. So it means that both of them have standard deviation of 1. And remember, the b value, the slope, is this. So I think one thing that I will do for you guys that might help is give you guys a list of formulas. I'll put in the test review materials folder later today. Yeah, if I go to one of my statistics folders here. So some of these forms are a little bit complicated, but I think B1 is what we're used to. Correlation coefficient is right there. B0 is the y-intercept, B1 is the slope of the regression line. B1 can be found this way or this way as well. So I think just those might help. So I might just take some screen grabs and kind of just put them in a different document and share with you guys. Standard deviation, some of the standard deviations are a little bit complicated. Don't worry about that so much, but I think having some of the formulas will help. Anyway, Coming back here to the practice test. So then you could solve for R, and because the slope was, oh, it's supposed to be negative. Okay, that's a typo. It's supposed to be negative 0.44. There you go. So R would be negative 0.44. So it looks like that was a typo. Okay. Sorry about that again, about the other error. You guys were probably working. No, it was correct here. Okay, so it's incorrect in the solution key. Got it. Then for number 8, Gabby, do you mind reading number 8 for us, please? And Gabby, are you there? No? Okay. Riley, can you read number 8, please?
Yeah. There is a linear relationship between the number of chirps made by the striped ground cricket and the air temperature. A least square fit of some data collected by a biologist gives the model. Sorry, what's that little?
Y hat.
Oh, y half.
Well, oh, yeah, Y then a hat because it has a hat on top of it.
Oh, got it. Y half equals 25.2 plus 3.3x, where x is the number of chirps per minute and y half is the estimated temperature in degrees Fahrenheit. What is the predicted increase in temperature for an increase of 5 chirps per minute?
Yeah, so all you have to do, so they want the predicted increase. You have to be a little careful there. So they're not asking how many, they're not asking for the temperature for 5 chirps. I mean, definitely let's plug in 5 for X, of course, because X is the number of chirps per minute. And if you work that out, so this is Y hat, 25.2 plus 3.3 times 5, which is 16.5. Work it out. Y hat is going to be 41.7, I believe. Now, what if a bird doesn't chirp at all? Then what's the predicted value? That's easy. That's just 25.2 straight up. So what's the difference between these two? So because they're asking for the predicted increase, and the difference between those two values is going to be 16.5. Or you could send 3.3 times 5. That would have been sufficient as well. So the temperature goes up by 16.5 degrees when a bird experiences an increase of 5 chirps per minute. That's what I interpret that one. Okay, then I'll quickly do 9 and 10. Then I think it might make sense to put you guys in a breakout session after that. We'll come back and answer any questions about the breakout session. Then I'll look at the free response with you guys at the end of class. So stop at 9 and 10. I'll kind of talk about these quickly. So Scatterplot shows a relationship between the number of people per television set and the number of people per position for 40 countries along the least squares regression line. In Ethiopia, there are 503 people per TV and 36,606 people per doctor. Which of the following is correct? Okay. So our regression line shows a positive slope. And if we look at that data point, 503, probably over here, and predicted should be about 15,000 people per doctor. Well, Ethiopia has 36,000 people per doctor. That's actually not good because you'd like to have a lower ratio, right? We don't have as many doctors living there. Definitely has a social justice component here for sure. So the actual data point's way up here. So our data point is definitely above the predicted value. So our prediction line is actually under predicting what's really happening in Ethiopia. So the other ones are kind of weird, like the slope is less than 1. No, actually the slope is more than 1, like you go up 5,000 over 100 people. So I wouldn't say that. The correlation can never be greater than 1, just so you know. The highest correlation gets 1. Increased number of TVs in the country will attract more doctors. No, actually, it might bring fewer doctors. Well, actually, we're not really sure, to be honest with you, because people per TV. So I guess if you had more TVs, then you have fewer people per TV. That's just hard to say. I don't think we can, because we're not really looking at that necessarily. And indeed, the point for Ethiopia is decreasing the slope. Actually, it'd be increasing the slope. It causes the change, to move up. So if you have a scatter plot like this, right, where here, this is fairly linear. But if I have a data point that's, like an outlier way up here, now my slope is going to becoming more steep, right? So that actually would not decrease the slope. So D is out. Either it was more people per doctor than expected, based on how many, yeah, definitely, because it's over our true value is above the predicted value. So you have more people per doctor, you don't have enough doctors there. So yeah, that's why it's D. In 5 for 10, then we're going to go to breakout room right around 1 o'clock. We'll do the breakout session actually for about 20 minutes. The scatter plot shows the lean body mass and metabolic rate for a sample of 5 adults. For each person, lean body mass is subject total weight in kilograms less any weight due to fats, the metabolic blah, blah, whatever. Okay, so be it. That's just what you got. And then we haven't really done this, so we're gonna have to ignore this part. Yeah, you know what? Actually, we'll have to ignore this question. We've not done anything like this. So sorry, let's just throw 10 out the window. Okay. So let's look at actual multiple choice questions. Let me kind of take a quick scan to see which ones are okay for you guys to try.
Mr. Almashni, I have a question.
Yeah, go ahead, fire
When
away.
you, I was just looking at number 12, and when it says to list the outlier, do you want us to give both the X and the Y, or just the Y
Number
in terms
12
of coordinates?
on. Well, I want both. You want to pick the point that seems like off, really off. So this seems really off right here.
So negative 19.4.
And the Y value goes with it as well.
And so 350.
330 or whatever, right? Something's close enough. Or you could just like circle it. I mean, you could say the one at X equals negative 19.4, which I think is pretty obvious, but if there's 2 points at that X value, then you want to give me the Y value as well. So if you can get both, that'd be awesome. So anyway, but we'll go over that in just a little bit. But I think as I'm looking through this, I think all these are fine. Just number 5 is kind of covering some old stuff. So you'll kind of need to figure out the z-score and normal distribution. So it's kind of a good review of old stuff. But I think the rest are all fair game. So yeah. So just 1 through 10, pages 1 through 5. Just so you know, the other pages that come after page 5, after page 6, my bad. So you're doing 1 through 6. Sorry, number 1 through 10 on pages 1 through 6. There's just the rest are just the answer key, and then the questions are repeated, just using a different order. So don't really think that there's all these questions you have to do. They really just repeat those questions. At least I think they do. Let me double check. Yeah, they do. I was got a little excited that there's more questions, more practice. So I'll put you guys in groups of 3. Work on just those problems. We'll do it for 20 minutes. We'll come back. We'll talk about those answers, then we'll talk about the free response, and we're done with class. So stop recording, stop sharing, stop recording.